think, the students, and make it having lots of fun. Thank you, Rossella, for being here.
Thank you, Paolo, for inviting me over, and Andrea Bonani, as well as Marco Marinello, and my PhD students. It's too fast, just a second, too many things, spoiler. So it goes here. And my PhD student, Joanna Terzi, and Bilal Khan for being here today. So what do we do? Well, I think it's best described by means of the photo you see here. We make. And we make in a lab which is nearby. So if at the end of today you want to come and visit the lab, which is the physical computing lab, we are in B1 at the Faculty of Engineering, and we are pretty welcome to welcome you. So say around 5 this afternoon. So let me just go ahead here, and let me start from the start, which is once upon a time. Once upon a time, I started working in the field of human-computer interaction with educational purposes. I come from automated reasoning. So my background is, let's say, in a specific field of artificial intelligence. That's my PhD. But at the time, I was working on a project that was related to an educational resource for children who are poor test comprehenders. So they read the test fluently, but they don't understand what they read. And working on this European project, I started learning that it doesn't only matter what comes in the background, but also in the foreground. So I have a jacket since then, okay? And the idea was, and still is, to try to generate as automatically as possible a series of games, so gamification was already there, and in order to stimulate children to train their reading comprehension by focusing on specific components of text. Now, this work that was in 2011 is getting back thanks to the work of another PhD student who is exploiting, let's say, constrained and controlled models of generating text and extracting text out of stories to semi-automatically generate better versions for people who have reading comprehension issues. So, games, fun to learn to read. From there, from the idea of play and playing and reading, we started thinking of something that doesn't have the traditional interface, so the screen in between people and what they have to learn. And there came the second wave, a long wave of PhD work with students who were willing to take what comes from game design, like a progression map for making clear where you are in your learning, and making it tangible. And so this was the work of Alessandra Melonio, who worked on gamification and created a series of physical and digital artifacts, to make children in primary school have fun while learning whatever subject they were learning and keeping track of their progress by playing on a HUD progression bar that was made interactive through Arduino and friends, okay? Now, from that work, what we notice is that children working in group had to learn to master how to take turn in conversations in order, for instance, to take decisions. And this was an observation that was evident in the field and that came through interviews with teachers that had participated in the previous project. From that observation, evidence in the field, came the idea of bringing something tangible that became turn talk in order to teach in a fun manner to children how to take turn in conversation and be rewarded in case the taking of turns would be balanced among the participants. And again, you also have Arduino and friends besides Raspberry Pi inside the tangibles for learning how to take turn in conversation. This is the PhD work of Mehdi Rizvi. Both Mehdi Rizvi and Alessandra Meloni are no longer here. They are professors in Venice and one in Heriot-Watt University in the UK. but let's say that the work continues along the dimension of play and making. The second wave of work that we do here is instead the following one. Instead of making something for schools that they can use in order to learn and have fun, we started thinking, why don't we make them make what they want? Okay? So this is the third wave. And it came through initially the work of Effichia Rumeliotti, who is now back in Greece and working with FPK in Trento, by the way. And what we did was to create a board game, okay, which you can see in the physical computing lab. And the board game would guide children from middle schools at that point to construct the pieces of their physical artifacts. Okay? So say, what are the input devices you can use? What are the output devices you can use? And what do you want this input device and output device to be used for? And especially, it was contextualized in the Talvera Park of Bolzano. So they had to play a game with the mayor of the town, clearly simulated, in order to be the designer of the new, more fun park, the Talvera Park, for middle school students. Now, why so? Because the idea is that when they are in middle school and then high school, they start to disconnect from nature, from the natural environment of Bolzano. And so we wanted to make them play and rethink how to make the park connected to them. The same idea is now in the PhD work of Joanna Terzi. I would like just to give her 1 minute, sorry.
Thank you very much. As Professor Gennari introduced, I'm working on how to reconnect with nature, again, using the same type of technology that you will see here, also in the following work. And what it shares in common with the previous example is the lack of screen, or else, in my term, the unobtrusiveness. Why is this important in this particular context? Because especially when it comes to artifacts located in natural environments, the importance is in remaining in the environment we are and being able to observe around rather than being focused on how the specific technology works.
Okay, so let me just go ahead, because this is further work along the same idea. So giving, let's say, people who are not expert, either in programming or designing an interaction, the means to do so, and to rapidly prototype their idea. So what came out is the work again with Medi for more complex type of interactions, playing cards by means of this, let's say, app that Medi created. They play card on the board, then they choose the card are replicated in the app, and the code, the program for the microcontrollers they use, that was the microbit, is automatically generated and deployed on the microbit. So they can immediately test their idea concerning what they would like to do as smart as possible in the new park, Talvera. And we did a similar approach also with artists, with refugees, so I'm just going ahead because I want just to focus on what we did with the schools in Bolzano. So thanks to a collaboration with Andrea Bonani, I started teaching teachers. And I started to teach teachers on how to use physical computing devices like Arduino, Microbit, Raspberry Pi, whatever you want to, partly meant for the educational market and some that are not for the educational markets with our intervention in between, so has to learn over different ways of making new things and have fun with their students. You see here me teaching during COVID how to use different, let's say, tools in order to enable teachers to learn how computing can be fun, okay? Now, this is another target population. Here we created another board game. This board game instead is, again, for enabling people with severe intellectual disabilities to make their own smart things for their own environments. You see now the board is different. It has no longer a childish, let's say, design, because it's meant for adults. And in particular, it guides them to immediately, even faster, prototype specific solutions for their environment. This is the PhD work of Marco Mores, who today is working with people with intellectual disabilities, exactly. Last but not least, I would like to introduce to the work of Bilal Khan, another PhD student who is working with us in the physical computing lab, that is, let's say, bringing this kind of work, making and having fun for playing, imaginative play, to another target population. Preschools, teachers, and children. Bilal, the floor is yours.
Hello, everyone. We started to design a few prototypes initially for the preschool children that should be used in their imaginative play activities. One of those digital prototypes was this Tira Tara. Children were invited to freely explore it. So let's say, so this would trigger their creative imagination, and they would reflect upon that one. And once they utilize these, use these digital artifacts, and then they created their own digital artifacts. And it provided us the basis to analyze their interaction and develop more generalized sort of toolkits that will help the teacher and children to create their own digital artifact. Whatever interaction they want, they could do that for themselves. So mainly we utilize is the cardboard material, the recyclable material, that the teacher and children by themselves can redesign their own digital prototypes. This was one of the heads that was used. It uses an RGB color sensor along with microbit. So children were asked to try different colors on this one. If they try with the black color on top of the sensor, it won't work. And so it works with certain colors. Let's say on the green color, it produces a chirping sound, so this creates their imagination, so they can try different sort of combination in order to utilize these artifacts in their imaginative play. So, thank you.
Okay, so this is the last part, which is about imaginative play, making artifacts for preschools and making them discover what's inside it, because these things are meant to be open, show what's inside. Children need to understand exactly what are the things that make the interaction work, and then they could imagine with the devices that Bilal had designed for them how to create their own artifact playing. And they created Strish Piano, which is again is on display in the physical computing lab. And you're welcome to come and see it. So the idea of the entire work we do is that there is research. Research doesn't live in a silos. It goes to society, but we also bring some ideas back. Okay? So it's a cycle. And in particular, we are bringing also students to the co-space, which is also a space dedicated to activities with schools for third mission of the Faculty of Engineering, and the software that runs on the computer that we use, you guess it's FUS. Okay? So these are some of the activities that we have already done with Andrea, with schools, middle schools, with high schools, and with teachers again. In particular, we run them with middle and high school so far. So they come there, they explore what we do, they learn of research, we learn what they need, and then we get back to them. But the idea of everything is to make them make and have fun together. I see it's over. So.
Thanks so much, Rossella, and thanks so much to you also for presenting your artifacts, beautiful artifacts, and for what you're doing for schools and teachers and students. Some questions.
Yeah, meanwhile you think of the questions, I just want to say that clearly this is me presenting, but this is not my work. It's everybody's work, it's the students' work, and the former members of the lab's work who are there, okay?
Okay, some questions from you?
There
Yes.
is a question there.
Amazing work.
Thank you.
Thanks so much for your presentation. This is a PhD program. So, in which made you can evaluate, measure the impact in the pupils where you go in the classes and so on to
Sure.
product
Good point. Sure,
paper.
absolutely clear. So it depends on the goal and depends on the PhD program, because here you have two PhD students coming from two different programs. Bilal is from the PhD in computer science, and Joanna is for the PhD with the Faculty of Design and Art and the Faculty of Engineering. So there are two different PhD programs. So first thing, the program. Second, the type of research that you do will also steer a bit the kind of impact that you can measure and assess. So, for instance, in the case of Bilal, what we do is to assess whether children, after playing with the artifacts that Bilal brings, according to the protocol that we have designed for them to play with them, with their teachers, are enabled to recreate or imagine something similar. What does it indicate? It indicates that what we uncovered was understood. So this is an indicator of an impact of understanding. Go back to the Terence project. The Terence project that was the European project concerning test comprehension. So you can create wonderful game, and they play. But if the games they play do not lead them to read better, it's a failure, right? So what is the indicator that the approach that we brought at the time, that was that of creating games for reading, worked? The indicator was that we started with the University of L'Aquila, that has people expert in reading comprehension. And what they do, they work with us on an experiment with 500 children. So they were pre-tested in terms of standard measures for test comprehension, post-tested after the intervention with Terence, and there was a control group too. The control group would only use what they use traditionally in schools. And at the end, we could show that there was a statistically significant difference in the number of children that after the intervention with Terence could read better than with the traditional intervention. Then we have an indicator that what we had done for making them play and understand better worked as expected. So it depends on the goal.